let's talk about dormancy. So, right, it's a stage with no leaves or evidence of any kind of real metabolism. There's a little bit going on, but very little. And it's kind of goes from November to April-ish. And we break it down into 3 stages. There's acclimation, as the vine gets used to the cold weather in the fall. And then it reaches a maximum of cold hardiness. Cold hardiness, it means like the ability of the vine to survive cold, right? Without like freezing and killing off parts of the vine. And then deacclimation, which happens kind of late winter, early spring, when things start to warm up and then sap flow starts to move through, right? And the metabolism comes back. Okay, so it kind of looks like this. So what you're seeing here on the y-axis is what's called a LTE 50. You see it there, LTE 50, which is lethal temperature exotherm 50, which is, and this is being expressed in Celsius here. It doesn't really matter, but it means that this is the temperature at which, like, if say at this point here, and say this is September 1st, if we got to -7 degrees, right where that line meets it, we've got the -7 Celsius on September 1st, then 50% of the buds on that grapevine would be frozen and die. Okay? So we use this as these LTEs as like a measure of cold hardiness. Then, of course, down here is time. So you can see acclimation. So the vine is through the fall. You can see it. The LTE 50 is going down for some reason. I'll tell you why that's happening. But the LTE 50 goes down, so it's less cold hardy at the beginning of fall, and then it is more cold hardy until you get to about midwinter, and then we reach maximum cold hardiness where the vine can withstand its lowest temperatures for the year. That's not saying that you're not going to get a temperature below this, and you might in some of these upper latitude regions, like here in New York. And then, so this is what's called endodormancy, by the way. This is when it's going into endodormancy, where the vine just kind of brings itself into dormancy. And then this is called ecodormancy or deacclimation here, where the vine, now the only thing that's keeping the vine dormant are the temperatures. So now once the temperatures start to warm up, then metabolism resumes, and then the vine comes out of dormancy and deacclimates and becomes more sensitive to cold. Okay? So the way acclimation works is it begins after shoot growth, and the shoots begin to brown and form canes. So the brown stuff is what we call periderm, and the buds lose water. So a bud has a lot of water in it during the growing season. About 80% of it is water, and then it loses quite a lot of it. And then also by doing that, it's concentrating the solutes within the bud, so thereby decreasing its freeze temperature. Right. So and it occurs generally. Acclimation begins sometime around veraison, which is, again, that's the start of color change. So that's kind of like August. So yeah, cold hardiness, like I said, it's the ability of the vine to withstand cold temperatures. And the degree of hardiness depends on a lot of different things, but things like environmental conditions. So if you have a nice cold spring or a nice cold fall, right, then the vine's going to lose more water, gain more solutes in those buds, and its LTE 50, like we just saw, is going to go down. But if you had a warm fall, unseasonably warm, then the vine's not going to acclimate as well, and then when you go into winter, it's going to be more sensitive to cold temperatures. Also, things like how much water you had in the soil. If your soils were really, really wet all year long, then the buds aren't going to lose as much water as they would have if they weren't as wet. Growing conditions, kind of growing conditions and environmental conditions are roughly the same. But some of this, like if a vine is very vigorous as well, so if a vine is a fast grower, that's what vigor is. It means like how fast the plant grows. If a vine is very vigorous, they also tend to be relatively less cold hardy than other vines. But of course, the inverse of that is true as well. So if a vine is also very like stressed and stunted, then it's going to not be very cold hardy either. So we're shooting for something in the middle there. Variety as well. Some varieties are more cold hardy than others. So the hybrids, like I've discussed previously, are pretty cold hardy, right? Because remember, hybrids are like Vitis vinifera combined with some of those North American species, which those North American species, essentially all of them, are much more cold hardy than Vitis vinifera. But also, even within Vitis vinifera, there's differences in how cold hardy a variety is. So Pinot Noir, not very cold hardy. Cabernet Franc, pretty cold hardy. Okay, and that's another reason why Cabernet Franc is a pretty popular grape here in the Finger Lakes. And then rootstock as well is going to play some role in cold hardiness. So if you have a really vigorous rootstock that provides a lot of vigor to the plant, makes the plant grow really quickly, then of course those plants are going to be less cold hardy, right? It's not necessarily the cold hardiness of the rootstock itself, because we don't really care. The rootstocks never really get hurt, right? They're the North American species. They're pretty tolerant of these cold temperatures anyways, but it's really more about the vigor conference that is the problem, okay? And the other thing that I should mention in here too is also just carbohydrates. So if a vine goes into the winter with quite a lot of carbs, they seem to be more cold hardy than vines that go into winter carbohydrate depleted. So that's also very important for grape growers in regions where they have cold temperatures, where the vines can be negatively impacted by those temperatures. So yeah, woody tissues tend to be a little more cold hardy than buds. So generally you see the buds die off before you'll start to see major vascular damage. And this is a bud, by the way. So a grape bud is actually what's called a compound bud. So it's multiple buds within one bud. You can think of it as kind of an insurance policy. So this here is what's called the primary bud. That'll have about 2 clusters in there. We call them cluster primordia. This here would be the secondary bud, which is, slightly smaller. It'll have about 1 cluster within there. And then in here is a tertiary bud, which is just vegetative. Okay, so if this bud dies, then the secondary will push, and if that bud dies, then the tertiary will push. It's not always that way. Sometimes they all push, and we have to thin that out, but that's kind of the idea here. Okay. What happens though is the primary bud is less cold hardy than the secondary, which is less cold hardy than the tertiary. So oftentimes you'll see that the primary will get frozen, and then the secondary and the tertiary will be okay. Sometimes all of them are frozen, but here, this is what you can see. So that's the primary there, and that's frozen out. All right, and then that's the secondary there. So in this case, you're going to get a little bit of crop, but it's going to be a smaller crop than what you would have had because this primary bud has been frozen. Okay? So yeah, this is kind of what things look like. So this was a freeze event in Walla Walla, Washington. So universities, I'm about to show you the Cornell University chart. But universities go out and take cold hardiness data for growers, and then they supply them to growers and let them know, hey, we think you probably have some kill in your vineyards. And that's what this is showing here, is a bit of winter kill. So when temperatures got down to here, this is when we started getting into the LTE 50s range. I think LTE 50 was like here. This was like LTE 10. This was 50. So yeah, this was a kill event that happened in middle of January in Walla Walla, Washington. The town's so nice, they named it twice. So yeah, it wasn't actually that bad. It was more in the low zones of vineyards that got impacted, where buds got killed. And the reason for that, of course, is because air moves like a liquid. So more like cold air is going to kind of go down slopes, and then it's going to pond in like divots in the land, right? Low-lying spots. So in those low-lying areas of vineyards, yeah, they got impacted, but actually a lot of vineyards came out of this okay. All right. This is what the graphs look like that the universities will put out. So this is from Cornell. This is some Cabernet Franc data. And what they do is actually go out, they excise buds from the grapevine. They put little thermocouples inside the bud, and then they put those thermocoupled buds into a freezer that they can lower gradually. They can lower the temperature of that freezer, and then when they see a little response on the thermocouple, right? So when water freezes, it releases a little bit of heat, right? It's the latent heat of fusion, is what it's called. So they can see that heat release, and then they know that that bud has been frozen and that bud died. And then they can, that's how they create these LTE 10s, LTE 50s, and so on. So this here is the actual temperatures being measured by a weather station. And then the green line represents the top. Once the blue line goes through into the green, the top of the green, then you've reached a LTE 50, or LTE 10 rather. Once you touch or go past the black line, you've reached LTE 50, so 50% of your buds have died. And then once you go to the end of the green there, then 90% of your buds have died. And here in the 2013, 2014 data, you can see here in January, they get to that LTE 90, right? So that was a pretty severe event, and there was a lot of vineyards that got impacted. A lot of dead vines that year as well, not just dead buds, but dead vines. So the 2014 vintage here in the Finger Lakes was much smaller than normal because of that event. Key operations happening during dormancy, of course, pruning. This is spur pruning. We've talked about spurs. You can see the spurs right there. That's a cordon, and then spurs. This is, of course, cane pruning. So these are going to be, he's cutting these canes down to size, and those are going to be laid down on the wire. Okay. Of course, we're doing things like fixing our trellising, of course, because a lot of times we don't have the opportunity necessarily to do that during the season while there's just a ton of other operations that have to get done. We just kind of let, a wire breaks and you go, it's fine, let's go. Or, I mean, you fix it, but yeah, there are some things you gotta fix the trellising in the winter. And then, of course, we bang posts in the ground, put trellising in, that sort of thing. Of course, you don't do this in the winter here in the Northeast because the ground freezes. But in most of the West Coast, it doesn't freeze, and so we do a lot of that operation in the winter. Okay, so then in February, March, they start to deacclimate, right? So now the vine's in what's called eco-dormancy, where it's just being held in dormancy simply by the temperatures. And so sap flow, like the sap begins to flow roughly February, March, which is influenced again by soil temperatures and also, of course, by soil moisture. If the soil is really dry, then there's really nothing for the vine to take up in terms of water. And also, of course, by rootstock as well. So Riparia gloire tends to be more phenologically advanced than other rootstocks like this one, 3309, which is a Riparia birupestris cross. And generally this starts, like sap flow will start when soil temperatures go above 45 degrees Fahrenheit. Yeah, what happens, how the vine does this is it actually breaks down starch and then increases the osmotic pressure within the roots, within the xylem, and then that is actually what is pulling the water up into the plant, and then the buds begin to swell. What happens to the grapevine during acclimation? Bud water increases from 50 to 80%. Shoot growth continues. Bud water content reduces from 80 to 50%. The buds begin to swell. Bud water content reduces.